Now this is a steel design according to Eurocode. Now I am showing you that how to design the structural steel members in tension. Now this is the stress strain curve. You can clearly see yield stress as Fy and all the ultimate stress as Fu. And when you design in tension members, you have to find out the tension resistance. We call it nt or rd, that is given by the small of these two, this blue color one, AFI over gamma m naught and 0.9 a net fu over gamma m2. Here gamma m naught is mood 0 safety factor, that is 1, and gamma m2 is mood 3 safety factor, that is 1.25 for Sri Lanka. And now I'm going to show you how to design the compression members. In order to design the compression members, you have to find out the compression resistance. That is NCRD. Compression resistance can be found using AFY over gamma m naught. Here also gamma m naught is 1. And when you go for finding the buckling resistance need to be found. The buckling resistance equation is x into AFI over gamma m1. Here gamma m1 is also 1, A is area, Fi is yield strength. But here we have this new factor, that is we call a reduction factor. That reduction factor is x. How to find that reduction factor? So in order to find this reduction factor, we have to go for this graph. This graph is available in table 6.2 of Eurocode code 3 part 1, that is buckling curve. We call it buckling curve. There are several curves A, B, C and D. First we need to find out which curve is applicable for our case. That can be found using table 6.2 Eurocode 3 part 1. These buckling curves are available here in figure 6.4 of the Eurocode 3 part 1. And in order to find the reduction factor, we have to find this lambda bar, that which is in x-axis. Lambda bar is equal to lambda over lambda 1. Lambda can be found Le over I is radius of gyration, L is effective length, and lambda 1 can be found using phi into square root E over Fi. And also lambda 1 is also equal to 93.9 into epsilon. So epsilon can be found using square root of 235 over Fi. So we can find epsilon using that lambda 1 and lambda. By dividing lambda by lambda 1, you can find out lambda bar. When you know lambda bar, you can select the buckling curve and go and find out this reduction factor x, that can be substituted in this buckling resistance formula, and you can find the buckling resistance. And when your load is less than this buckling resistance, your member will not be buckled. And the other major designs are structural steel beam designs. When you find out when you are going to design the structural steel beams, you have to find out resistances and stabilities. When you go for resistance, you have three types: bending resistance, shear resistance, bending and shear resistance. When you go to find the stability, you have to find the lateral torsional buckling. So let's look at these three: bending resistance, shear resistance, and bending and shear resistance. When you go for bending resistance, you have three equations for class 1 members, class 1 and class 2 members, one equation, class 3 members the other one, the class 4 members the other one. You have three different equations, and using these equations you can find out the bending resistance. So if that bending resistance is larger than your bending moment, that means your member is safe. When you go for bending and shear, both of them, you can go for these equations. Here you have to find out rho, and a reduced yield strength is used as 1 minus rho into Fi. So this can be found easily when you know the shear force. And when you go for this shear resistance, you have this shear resistance equation here, but shear buckling occurs only if HF over FTW is high. That means if it's larger than 72 epsilons, the shear buckling happens. You have to check that first. After that you can go for this shear resistance formula, A or into Fy over root 3 over 1 over gamma m naught. So AV is defined here very clearly. That is the area, that is shear area, that means the area of the web. So by finding out that area, you can go for this shear resistance. If your shear is less than this shear resistance, that means your member is safe. So the last check is to check whether it is happening the flexural buckling in compression. Actually, buckling is found out using this buckling resistance, but here we need to find out the lateral torsional buckling in bending. So those two are different, buckling and lateral torsional buckling. The buckling can happen in only in the compression members, but lateral torsional buckling can be happen in beams, because the top part of the beams are in compression, and only one top part can be buckled. We call it lateral torsional buckling. So that uh, resistance, lateral torsional buckling resistance, can be found using this formula XLT. There is you can there again you can see a reduction factor, and WY is section modulus, Fy you know, MIM1 you know. So here using this equation, you can find the buckling resistant moment. Here you have these methods very easily, you can do it easily, and those are the major equations to find out the major iconic stresses, iconic things, the major resistance formulas are those.